Can a machine learning model describe harness races in a meaningful way, or is it just another overfitted spreadsheet? In this video, I'll walk you through 4 simple scatter plots that show how my current baseline model behaves against reality and against the market odds, and what that tells us about the quality of its predictions. Before we dive into the plots, a quick note on one metric you'll see a lot: Spearman correlation. You can think of it as a number between -1 and +1 that measures how similar two rankings are. Let's start with this first plot. Each dot here is one race. On the x-axis you see the model's accuracy, the share of horses placed on the exact correct finishing position. On the y-axis you see a scaled up top 3 hit rate. 0 means none of the model's top 3 horses actually finished in the top 3, and 1 means the model found the entire top 3 in that race. You can see that overall accuracy stays fairly low. The model rarely gets a lot of positions exactly right, but the top 3 hit rate is often much higher. There are quite a few races where the model doesn't nail the exact order, still manages to include 2 or even all 3 of the real top 3 horses in its own top 3 list. Now let's look at the same idea, but with a different x-axis. Here the x-axis is Spearman correlation between the model's ranking and the actual finishing order in each race. The y-axis is again the scaled top 3 hit rate. On the left side, where Spearman is negative, the top 3 results are mostly poor. The model hardly finds any of the real top 3. But as we move to the right and the correlation becomes positive, especially around 0.3 to 0.7, the dots climb up. In those races, the model tends to find 2 or all 3 of the actual top 3 horses. Next, let's bring the odds into the picture. In this plot, the x-axis is Spearman correlation between the model's ranking and the ranking implied by the odds. High values mean the model likes the same horses as the odds. Values near 0 mean they don't really line up. Negative values mean they almost disagree. The y-axis is still the scaled top 3 hit rate. When the correlation between model and odds is low or negative, the top 3 results are usually weak. Those races on the left rarely produce good top 3 hits. As the correlation climbs into the 0.4–0.8 range, we see many dots up at 0.67 or 1 on the y-axis. In other words, when the model and the odds agree about who belongs near the top, the model often does a solid job at finding the actual top 3 as well. Finally, let's look at the combined view of model, odds and reality. Here the x-axis is Spearman correlation between the model and the odds, and the y-axis is Spearman between the model and reality. Each dot is still one race. In the bottom left corner, the model is out of sync with both the odds and the actual result. As we move to the right, the model lines up more with the odds, and the dots also tend to rise. Races where the model is close to the odds are also the races where the model's ranking matches reality better. So what can we take away from these 4 views of the baseline model? First, even in its current simple form, the model can often pick out the right horses near the top of a race, without being perfect on the exact finishing order. That's encouraging for any downstream use where you mainly need a short list of strong contenders, not a flawless ranking. Second, the scatter plots show that the model's best behavior appears in races where its ranking is reasonably consistent both with reality and with the odds. When the model's understanding of the race collapses, performance drops across all metrics. Third, this is clearly a baseline, not a finished system. There is no strong evidence yet that it systematically outperforms the information already baked into the odds. Instead, it behaves more like a diagnostic tool. It helps to identify races where the structure is clear and the current features are enough to describe what happens. From here, the development work goes in three directions: adding richer features that capture track conditions, driver behavior, and race dynamics, improving the model architecture and regularization so that ranking quality is more stable across different race types, and studying the races where the model and the odds and the reality disagree to see whether better features or models can turn any of those disagreements into consistent, useful signals instead of noise. I will revisit these same plots in future videos as the model evolves, so we can literally watch the point clouds move as performance changes. If you'd like to follow that journey from this honest baseline to a more refined predictive model, subscribe to the channel and tell me in the comments which metric or plot you would like to explore more deeply.